Yeah. Okay. More questions? Good. Then we go to the company. Okay. That up there probably doesn't work anymore. It's a link to our conference. It does? Okay. That up there still works. Thank you, Leo. It gets you to our publication and you can download it. And now officially, so I don't have to slidey slide. It will turn itself off at some point, but currently we still have this. Okay. So overview. I'm going to pontify a little bit on continuous integration and then later on come to what we're actually doing behind it. It's going to be lightweight on that second part, but I've got lots of pull slides for that. So first I want to talk about what continuous integration is and why it's relevant. I'm giving you the anatomy of a CI system. I'm giving you the challenges of CI with models and how we're reusing things to get around these challenges. And then a showcase of tools. So, okay. Now everybody who's heard continuous integration for the umpteenth time, go get a coffee, please. I had a forum full of researchers. They all sit at their desks, largely by themselves, and they may not ever think about this. I also had a couple of industry architects who work with Eclipsey clickety-click things also by themselves. So to them, the actual story of what continuous integration means and how it connects is a relevant one. So what is it? Well, you produce something, a piece of text, a model or drawings, whatever, and you check it into a version control system. Some magic key combination, your files go flying across the wire and land somewhere else. And that is noticed, not by a person, but by a computer, by a robot. And that robot retrieves your change. Now, what you've changed will have implication down the line somewhere. There will be a process where you assemble, check, deploy, do whatever. So you have some instructions as to what ought to happen with the thing that you just changed and how it interrelates with the other things that are already there. So the server will carry out these instructions. It will do what you told it. If you told it to bake a cake and you just changed it from cherries to blueberries, then you'll get a blueberry cake at the end, hopefully. You made a mistake and you put tomatoes in, you'll get an unholy mess. And you want to know that very early. So, and that's exactly what the server does. If the cake is distasteful because it contained tomatoes, you'll get an unusual flavor exception. Sorry. Okay.
Did that joke go down well at the conference?
Not with the French. Okay, so that sounds pretty full on, baking a cake every single time somebody changes a single ingredient. Do I really need to do that? Well, you work with others in a team. So you want to make sure that every little change that you make is agreeable with what the others are thinking. If you're mucking up the recipe entirely and you notice right before you have the big celebration, a few little muffins would have probably been a good idea to check on things. So if you work with others, CI is a good idea. Do it. If your process has more than one step, and every complicated recipe, every build is more complicated. That's why we've got a job, because we do complicated things. If it was trivial, or everybody be doing it. So if your process has more than 2 steps, say, then you would also want to repeat the steps automatically. And you don't want to do that by that because your work hours is too expensive. So let the robot check it. And finally, if your results need to have any sort of quality, you can just mix something up and hope for the best, but that's not usually what we can deliver. So if you want something to be checked and that takes even more time than building it, then you will also need to have this process. So CI is the backbone of any working enterprise, not just a software enterprise, but probably any enterprise these days. Okay, how does it actually, how do you actually set this up? Well, if you go to a page on GitHub or any page that describes process, but this is for technical processes, it usually starts with get yourself a computer, then get yourself an operating system and install it, and it will tell you which. Then download this tool and install it, and then, so that's where we've got the computer. Then copy the files that you find here. Then type in these magic commands, and then save what you've got on a disk, and now you can install it and use it somewhere else. This is the result. Oh, wait, this is only half of it. You've just built the client. You also need the server. So now you need to copy that and repeat the process for that particular thing. Oh, you need a different operating system for that. So you may have different stages to assemble your result. The first stage used to be the horrible part. It used to be that it was very, very hard to set up a computer for your particular purpose. That's gone away with what we now know as containers. A container is basically a web address where you can download a completely installed computer. You say, this address, the computer comes down, it opens up, you type your commands in. And we can make the server do that. So that's why containers are so relevant to us. And the CI system is then nothing but creating containers, typing in commands, reporting on the flavor, and passing artifacts down if we have multiple stages. And that's what it looks like. This is the picture from our presentation. Good. Missioning on DevOps completed. Now, this is what my boss said. He said, well, we need some models on CI. And I say, what do you mean? And he said, well, basically, we need EMF, XML, JSON, YAML, and maybe we need some more other things, like what you can imagine, what people bring, and maybe databases and relational data and all of these things. Really, all of Eclipse would be good. And I go, oops, how do I make this happen? Because there's a problem with CI with models. We've got so many great Eclipse-based tools, but they're all tied to this window. And for the process we saw before, we don't have a window. We just type in things in a text box. So it doesn't really work together. There is no keyboard action, there's no process language, there's no container we can reuse. So there is no CI, so there is no collaboration, there's no quality, no control, and effectively, it's not very engineering-like. And that's what models have ailed with for such a long time. We've got great abstraction, but we're not actually able to get it to the wheels, to the actual industrial process. So it's a sad flower, sort of. Eclipse and Ant play together in this space. So there is a historical build system that was used in Eclipse, which is the Ant build system. And because it was used to build Eclipse itself, it was run very frequently. So it still has fairly good support. It's got editors, debuggers, configuration help, and it has the headless support via an Ant runner. So there, the window of Eclipse is chopped off, and we were left with something that we can use inside a container. So we can reuse the model-driven parts in that. This is a diagram that I've taken from the Epsilon website, so that's the credit here. That's how Ant usually is designed. So you have a project, and the project has several large-scale units called targets, and then there are the actual little steps that are being done. So here we've got the project has the targets, the target has the tasks, and then the tasks have little attributes on them. This is the same thing, but it does work with models most of the time. So here a model is being loaded, and then another set of models is being loaded over. And in the middle is a little bit of model-driven program that works with them. So that is the sort of thing we can now do. It's an actual process over a model, not over a piece of software, but over models. And that we can do not just for the Epsilon tool set, but for any other tool set that exposes in Eclipse. And if it doesn't, then we can make it expose in that space. And this is how the process works. So I talked about you commit your file, then the ARNT runner starts inside the container. It creates the ARNT project. Then there is a model task. It works with EMF, and then it goes all the way back. We've called it the bot builder, and because in the company we've got lots of affinity to the most beautiful fantasy ever written for things happening in space, we got the ball rolling with this one. Built-in tasks. That's what you can get off the shelf with ARNT. This is the scope of sort of tasks that are available just for you to work with. So if you need to, say, remote control a server, log statements, copy files, generate documentation, send emails, check coverage and stuff, there's a fair bit that you can already use. The file stuff is probably the most important thing. Some of the Java things are still useful regardless. This is an overview of the languages that are in the publicly accessible things that Epsilon and AMA, Atlant, Toolkit contribute. So you see, you can check constraint language, you can load models, convert them, compare them, make sample models automatically, transform, match the patterns, and most importantly for us, do the templating. So all of that is nothing we had to invent. We just took it. Okay, so finally, some questions on the bot builder that I've received during the conference. How robust is it? Well, we trusted in so far that our next generation products run on it, and that we are organizing our business workflows around it. So must be something that we have a fair amount of trust in. Can you have it? Ask my boss. There's a recipe in the article. You can re-implement it, but the implementation at this time is internal. So if you want it one for one, you have to ask. Can we help you? Yes, we can provide consultancy. You asked the same person about that. But generally, we're happy to see our technology used. Okay. Yeah, and that's our 3 grades that we had. That's the boss I talked about. He's always got a smile, and then he says something, and you need to scram to get it to work. It's fun to work with him. That's Sam. The steel look is she can crack any code, and that's me. I don't know what I'm doing there. Thank you very much. Thanks for listening.